So in this session, we want to solve a few more questions based on matrices. In this question, the matrix A, B and C are given. We are supposed to find A square minus A plus BC. So let's find the different components of this question. The first component that we have to find is A square. Then let us find the component BC and then we will just combine the terms that we have. So let's find these different components now. So A square would mean A multiplied by A, which is basically 4, negative 2, 6, negative 3 multiplied by 4, negative 2, positive 6, negative 3. So let's multiply these terms now. So the resulting matrix is going to be a 2 by 2 matrix, which will have 2 rows and 2 columns. So let's write that. We have a 2 by 2 matrix now. This is going to be first row, first column, first row, second column, second row, first column, and second row, second column. So for the first row, first column, we take the first row of the first matrix and first column of the second matrix. So 4 4s are 16 and minus 2 into 6 is minus 12. Then first row, second column. So 4 into minus 2 is minus 8 and minus 2 into minus 3 is plus 6. Then 6 minus 3 and 4 6 4s are 24 and minus 3 into 6 is minus 18. And then we have 6 into minus 2 is minus 12 and minus 3 into minus 3 is plus 9. And therefore A square becomes 16 minus 12 is 4, minus 8 plus 6 is minus 2, 24 minus 18 is 6 and minus 12 plus 9 is minus 3. So this is the matrix A square. Now let's take up the matrix B into C. So BC is going to be the matrix B, that's 0, 2, 1, negative 1 multiplied by C, which is negative 2, 3, 1, negative 3. So now let's again find the resulting matrix. So this is again a 2 by 2 matrix. So for a 2 by 2 matrix, you will take the first row, first column. So 0 into negative 2 is 0 and 2 into 1 is 2. So that's 2. Then first row, second column. So first row and second column. 0 into 3 is 0, 2 into minus 3 is minus 6. Then second row, first column. So 1 into minus 2 is minus 2. Minus 1 into 1 is minus 1. So minus 2 minus 1 is minus 3. And then second row, second column. So 1 into 3 is 3 and minus 1 into minus 3 is positive 3. So 3 plus 3 is going to be 6, right? So now we have A square minus A plus BC. Now what is A square? A square is 4, 6, negative 2, negative 3. Then minus A. So minus of 4, negative 2, 6, negative 3. And plus the matrix BC. So BC is 2, negative 6, negative 3, positive 6. And now if I notice, the first two matrices are exactly equal, absolutely no change. And therefore, I would simply go ahead and cancel this. So A square minus A cancels and therefore the answer is 2, negative 6, negative 3 and positive 6, right? So this is how we find the value of A square minus A plus BC. So let me again pause for a few seconds before I move on to the next question. Okay, moving on to the next one. So it's given that the matrix A is 1, 4, 0, negative 1. The matrix B is 2x, 0, negative 0.5. We have to find x if matrix AB is equal to BA. So it is given that the matrix AB is equal to BA. So we have to find the values of x. So let's now first find A into B. So A into B is going to be 1, 4, 0, negative 1 multiplied by b, which is 2x 0 minus 0.5. And this is going to again be a 2 by 2 matrix. So 2 by 2 matrix will again have first row, first column, first row, second column. So first row, first column, first row, second column, second row, first column, and second row, second column. So for finding the first row, first column, let's multiply. 1 into 2 is 2 and 4 into 0 is 0. So this is going to be 2. Then 1 into x is x and 4 into minus 0.5 is minus 2. So this becomes x minus 2. Then second row, first column, 0 into 2 is 0 and minus 1 into 0 is 0. And second row, second column, so 0 into x is x and minus 1 into minus 0.5 is plus 0.5. Therefore, this is the value of the matrix AB. Now let us find BA. So if I have to find BA, I would multiply B first. So B first and A next, right? So let's find the value of B into A. So 1, 4, 0, negative 1. This is the matrix B. This is the matrix A. Again, let's multiply. The result is again going to be a 2 by 2 matrix. So first row, first column, 2 into 1 and x into 0. So that's 2. Then first row, second column. So 2 4s are 8. 8 and x into minus 1 is minus x. So this is 8 minus x. Then second row, first column. So 0 into 1, 0. 0.5 into 0, 0. So this is 0. And second row, second column. 0 into 4 is 4. And minus 0.5 into minus 1 is plus 0.5. So now if you compare the corresponding elements, you get the element 2 is equal to 2. So we just leave that. 0.5 is 0.5. And the element 0 is 0. And the element x minus 2, I think that's the one which is going to be of use to us because that contains x and we have to find x. So I will say that since the matrices are equal, the corresponding elements are equal. And therefore, I will say that x minus 2 is equal to 8 minus x, which means 2x is equal to 10, and that implies x equals 5. Therefore, the value of x is 5 in this particular question. So here I multiplied AB and BA and I just equated them and used the idea that if two matrices are equal, their corresponding elements have to be equal. So again, let me pause for a few moments before I move on to the next question. Okay, moving on to the next one. Okay, consider this question. The matrix A is given. We have to find the value of K if A square is equal to 8A plus Ki. So let me first find the value of A square. So A square is going to be A multiplied by A, which is 1, 0, negative 1, 7 multiplied by 1, 0, negative 1, 7. So now this is a 2 by 2 matrix, so I can find the elements very quickly now. So I first take first row, first column. So 1 into 1 is 1, 0 into negative 1 is 0, so this is 1. And then first row, second column, so 1 into 0 is 0, 0 into 7 is 0. Then I take second row, first column, so minus 1 into 1 is minus 1. And 7 into minus 1 is minus 7. and second row, second column. So negative 1 into 0 is 0. 7 sevens are 49, right? So this is equal to a square, which is equal to 8 times a, that is 8 times 1 0 negative 1 7 plus k times I. So I is 1 0 0 1. So now what I can do is I can combine the elements on the right hand side, right? So I can say that the matrix 1 0 negative 1 negative 7 is negative 8, right? So negative 8 and 49. So let's note that down, is equal to, now let's see what happens here. 8 ones are 8, 8 zeros are 0, 8 into minus 1 is minus 8, and 8 sevens are 56. Plus k times the identity matrix would be k0, 0k. And now I can add the matrices on the right hand side. So the left hand side is sorted. It is 1 0 negative 8 49 is equal to, now it becomes 8 plus k, 0 plus 0 is 0, negative 8 plus 0 is negative 8, and 56 plus k. So now I can equate the corresponding terms. I get 1 is equal to 8 plus k, and 49 is equal to 56 plus k, and this implies k equals negative 7, and this equation also implies k equals negative 7, which means k is equal to negative 7. Now the critical question is, what if both the equations didn't give us the same value of k? If one equation gave me negative 7 and the other equation gave me, say, positive 7, then there is no value of k which satisfies the given equation, because I cannot have a different value of k here. Okay, so suppose I took k as negative 7, and this condition did require k to be something else, then the two matrices are never going to be equal to each other, right? So whenever you solve for k, since it's a single variable and it's a linear equation here, this is not even a quadratic equation. Because this is a linear equation, you should get a single value for k. So that is what we saw from this particular problem. Let me again pause for a few seconds and then we will continue. Okay, moving on. Solve for the matrix X where this equation should be satisfied. Okay, so now let's understand how this particular question should really be solved. See, it's given that the matrix 4 1 when multiplied by X should give me negative 4 8 and negative 1 2. Right? This is given to me. The most important thing is I should first find the order of the matrix X. So what is the order of the first matrix here? This matrix is 2 by 1. What is the order of the last matrix? It is 2 by 2. So now from this I should guess the order of matrix X. So let's start guessing. For multiplication to be possible, the number of columns in the first matrix should be equal to the number of rows of the second matrix. So the number of rows in matrix X has to be 1 by the order of the resulting matrix is 2 by 2. So this 2 is getting mapped here, and therefore if the order has to be 2 by 2, then this order has to be 1 by 2, right? Only then multiplication is possible. So I will say order of the, so let order of the matrix X, let order of matrix X be x a by b, right? Now a should be equal to 1 because the number of rows of x should be equal to the number of columns of the first matrix, right? And b should be equal to 2 because the order of the resulting matrix is 2 by 2, correct? So we have first figured out the order of this particular matrix. Now if the order of matrix X is 1 by 2, then I can say that, so let the matrix X be, see 1 by 2 means there is going to be 1 row and 2 columns. So let this be A and B, or since I have already used the variables A and B, let me use some other variables here. So let me use say M and N. Okay, so let the variables be M and N. So now that I have found the order, now let me go ahead and find the variables M and N. See, if I want to find the matrix X, then I have to find the variables M and N, correct? So now let me perform the multiplication. So I have 4 1 multiplied by M N, right, is going to be equal to negative 4, 8, negative 1, 2, right? So now how do I perform the multiplication? This is a 2 by 1 matrix. This is a 1 by 2 matrix. So I'm going to have a 2 by 2 matrix. How do I get my 2 by 2 matrix? I take the first row, first column. So that's 4m. Then I take the first row, second column. That's 4n. Then I take the second row, first column, that's 1 into m is m, and then second row, second column, so that is going to be equal to n. This is equal to negative 4, 8, negative 1, 2. So now you can equate any of these elements. So I will equate m is equal to negative 1, right? Therefore I can say m is equal to negative 1 and n equal to 2. Because these are the corresponding elements. So the reason is equal matrices have equal corresponding elements, right? And now let's do a quick check. If m is equal to minus 1, 4 into minus 1 will be minus 4, perfect. And if n is equal to 2, 4 2s are 8, that also matches, very good. So our values of m and n are consistent, and therefore the matrix X is negative 1 and positive 2, right? So in this problem we were able to first find the order of the unknown matrix, and once we found the order of the unknown matrix, we constructed that matrix using some variables. Like over here I used the variable m and n. And then I was able to find out the values of m and n using the concept of matrix multiplication and equality of matrices. So that is how I approached this particular problem. Let me pause for a minute. Moving on to the next question. Consider the following question. Solve for x. Again, here we have a matrix whose order is, so let's write the orders here. The order of this matrix is 2 by 2, and we need to find the order of x, and the order of this matrix is 2 by 1, right? So the matrix that we first have is a 2 by 2 matrix. We have to find the order of x, and that is going to lead to a 2 by 1 matrix. So now let's find the unknown values for the order of x. So I can say that if this is a 2, then the number of rows of x should also be 2. And if the resulting order is 2 by 1, that means this is going to be 2 by 1, right? Therefore, the order of x should be again 2 by 1. So again, I would say the number of columns of the first matrix should be equal to the number of rows of x, therefore the number of rows of x is 2, right? And similarly, the resulting matrix has order 2 by 1, which means the number of columns of x is going to be 1, and therefore the order of matrix x is 2 by 1. So this is a very important conclusion that we have reached, and because the order is 2 by 1, I can now say let the matrix x be 2 rows and 1 column. So let it be, say, A and B, right? So this is 2 rows and 1 column. Now we need to find the variables A and B. So let us do one thing. Let us now start our matrix multiplication. So let's take 8, -2, 1, 4 multiplied by AB is equal to 12, 10, right? So this becomes, now again, this is a 2 by 2 matrix. So I take the first row, first column, that's going to be 8A -2B, and second row, first column, that is A plus 4B. Yeah, this is equal to 12, 10. So now I can say that since matrices are equal, I can equate their corresponding elements, which means 8A minus 2B is equal to 12 and A plus 4B is equal to 10, right? And therefore, if I solve these two equations simultaneously, I will get A and B both equal to 2. And therefore, the matrix X will be equal to 2 and 2, right? Because it is AB, therefore the matrix X will be 2, 2. So now you can actually go and check. You can multiply the first given matrix with the matrix 2, 2, and you will get 12 and 10 on the right hand side. Yeah. So this is how we solve this particular question. Pausing for a minute and then continue. Moving on to the next one. Consider the following question. Find the matrix B if this multiplication holds true, where I is the identity matrix. So what it means is, we have 6, 5, 5, 6 getting multiplied by a matrix B, and that has to be equal to 11 times identity matrix is 1, 0, 0, 1. Which means, now I first need to find the order of the matrix B. This is a 2 by 2 matrix and this is also a 2 by 2 matrix. Which means the order of B is going to be 2 by 2. So I can say that again, I can write number of rows of B should be equal to the number of columns of the first matrix, and that should be equal to 2. And similarly, the number of columns of B should be the number of columns of the resulting matrix, right? And that should also be equal to 2. Therefore, the order of B is 2 by 2. So this is one very important conclusion. And order of B is 2 by 2. Basically, this means that now I can write the matrix B. So matrix B is A, B, C, D, right? And therefore, I can start the multiplication. So multiplication is 6, 5, 5, 6 times B is A, B, C, D is equal to, now 11 times identity matrix will be 11, 0, 0, 11. And now let me perform the multiplication. So first row, first column. Of course, the resulting matrix is a 2 by 2 matrix. So we know that. And therefore, I would multiply. So 6A plus 5C, that's the first entry. 6A plus 5C. Then take the first row, second column. So 6B plus 5D. Then I would take 5A and 6C. So 5A plus 6C. And then 5, 6 and BD. So that would be 5B plus 6D. And then I would equate the corresponding matrices. So I get 6A plus 5C is equal to 11. And 5A plus 6C is equal to 0. That's one set of simultaneous equations. Similarly, 6B plus 5D is equal to 0. And 5B plus 6D is equal to 11. So that's the other equation. Now, because the coefficients are swapped here, I can simply add the two equations. I can use that technique, and solving these two simultaneous equations, I can get the values of A and C. So when I add these two equations, I get 11A plus 11C is 11, which means A plus C is equal to 1. And therefore, I will get 5A plus 5C. 5A plus 5C is equal to 5, and then I can solve these two equations. So if I solve these two equations and subtract, I get A is equal to 6, and let's see. So A equals 6 and C equals -5 is what I get. And similarly here also, if I solve, I will get B equal to 6. Let's see. So adding these two equations, I get B plus D is equal to 1, right? So I think I will get B is equal to -5 and D is equal to 6. So B equals -5 and D is equal to 6. And therefore, the matrix B would be, so the matrix B would therefore be A, that's 6, B is -5, C is -5, and D is 6. So the resulting matrix is 6, -5, -5, 6. So over here again, I first found the order of the unknown matrix, and after multiplication, I equated both the sides of the given equation, and I found my variables. Okay, moving on. So in this question, we have to again solve for x. So again, let's find the order of x. So the order of the first matrix is a 2 by 2 matrix. I have to find the order of x, and the order of the resulting matrix is a 2 by 1 matrix. So naturally, for multiplication to be possible, right, the number of columns of x, a number of rows of x should be 2. Only then multiplication is possible. And because the number of columns in the resulting matrix is 1, this value has to be 1. So again, you will write the number of rows of x should be equal to the number of columns of the first matrix there, and the number of columns of the second matrix. The number of columns of x should be equal to the number of columns of the resulting matrix, right? Of the resulting matrix, and therefore order of x is 2 by 1, right? And because the order of x is 2 by 1, I would say let the matrix x be. It's a 2 by 1 matrix, which means 2 rows and 1 column. So let the matrix x be AB. So now I have 8, -2, 1, 4 times AB is equal to 12, 10. So let's perform the matrix multiplication. So we get 8A, -2B, and 1A, +4B, right? That is when you multiply, is equal to 12, 10. Okay. So first column was 8A, -2B. That is how I got this. And 1 into A was A and 4 into B was 4B. So A plus 4B was 10. So now equating the corresponding elements. So equating the corresponding elements of the two matrices, what we get is 8A minus 2B is equal to 12 and A plus 4B is equal to 10. So now if you solve for these two equations, what you will get is, let's multiply the first equation by 2. So 16A -4B is equal to 24 and A plus 4B is equal to 10. So solving for A, adding, you get 17A is equal to 34, which means that A is equal to 2, right? And substituting A as 2, so if you substitute A as 2, you get B also is equal to 2, and therefore the matrix X is 2 and 2, right? So this is how we can find the value of the matrix X. So again, the strategy was same. We first found the order of the matrix X and then we use some variables here to find the unknown matrix. So let's move on to the next questions after a pause. Okay, moving on. Okay, consider this question now. Find the matrix X so that 2AX is equal to B, right? So let's understand how to go about this question. It's 2 times the matrix A is given. So A is 2, 3, 0, negative 2 times X is equal to B. So B is negative 8 and positive 8, right? And now this 2 can be multiplied with all the elements. So it gives us 4, 0, 2 3s are 6 and 2 into minus 2 is minus 4 times X is equal to negative 8 comma positive 8. So let us write the order of the given matrices. This is a 2 by 2 matrix and this is a 2 by 1 matrix, right? So we should find the order of A. So the first matrix is a 2 by 2 matrix. Then you have X and then you have a 2 by 1 matrix. So now the number of rows of X should match the number of columns of the first matrix and the number of columns of X should match the number of columns of the resulting matrix. So again you can write all the justifications and you can say that the order of matrix X is therefore 2 by 1, right? This is a very important conclusion. And therefore, if the order is 2 by 1, let's assign the variables immediately. So X is therefore 2 rows and 1 column. So that's A and B, right? So now I can say that the multiplication is 4, 6, 0, negative 4 times X. X is A and B is equal to negative 8 and positive 8. So now let's multiply. So we get 4A plus 6B, 4A plus 6B and then 0A minus 4B. So that's minus 4B is equal to negative 8 comma positive 8. And now I can equate the corresponding elements. So I get 4A plus 6B is equal to negative 8 and negative 4B is equal to positive 8. So this means B is negative 2, right? And I can substitute B as negative 2. So substitute B as negative 2. You get 4A plus 6 times negative 2 is equal to negative 8, which means 4A minus 12 is equal to minus 8, which means A is equal to 1, right? And therefore, I can say that the matrix X is 1 and negative 2, right? This is the matrix X. So again, pausing for a few seconds before moving on. Moving on to the next question. So we have to find the matrices P and Q if the following equations hold true. So this is a simultaneous equation. Instead of the variables, we just have matrices. So our treatment is going to be exactly similar to solving simultaneous equations. Let this be the equation 1 and let this be equation 2. I have decided to eliminate P. So I'm going to multiply the first equation by 3. So that gives me 6P plus 9Q. And 3 times the matrix on the right side is 3, 51, 30 and negative 6. and then the second matrix is multiplied by 2, so I get 6p plus 8q, which is equal to 6, 50, 26 and negative 4, right? And now if I go ahead and subtract these two equations, I am going to get the matrix Q, isn't it? Because the matrix P will get eliminated. So 6P minus 6P cancels. 9Q minus 8Q is Q, which is equal to 3 minus 6 is minus 3. 51 minus 50 is 1. 30 minus 26 is 4. And negative 6 positive 4 is negative 2. So this is the matrix Q. And therefore, I can now substitute the matrix Q in the given equation to find the matrix P, right? So now what we get is 2P. So 2P plus 3 times Q. Q is negative 3, 1, 4, negative 2. And that equals 1, 10, 17 and negative 2. Therefore, this becomes 3P plus 3 into negative 3 is negative 9. 3, 12 and negative 6 is equal to 1, 17, 10 and negative 2. So now I can shift the matrix to the right hand side. So I get 1, 17, 10, negative 2 minus negative 9, 3, 12 and negative 6. So therefore 2p becomes 1 plus 9, 17 minus 3, 10 minus 12 and minus 2 plus 6. Therefore, 2p becomes 1 plus 9 is 10, 14, negative 2 and 4. And this implies p is equal to half of this matrix. So half of this matrix is going to be 5, 7, negative 1 and 2. So this is how we solve for the matrices p and q under the given conditions. Yeah. So the treatment of this particular problem was exactly like simultaneous equations, absolutely no difference. And once we found matrix Q, we substituted the value of Q of the matrix Q to get the matrix P. So pausing for a few minutes. Okay, next one. In this question, I have to find the variables x and y. The matrix X is given as, the condition given here is x square. So x square is equal to x times x plus y times I, where I is the identity matrix. Let us spend some time in finding x square first. So x square would be 2, 3, 1, 2 multiplied by 2, 3, 1, 2. So this is a 2 by 2 matrix. So first row, first column becomes first row. Take the first row and first column. So 2 2s are 4, 3 1s are 3, 4 plus 3 is 7. First row, second column. So 2 3s are 6, 3 2s are 6. 6 plus 6 is 12. Second row, first column. So 2 plus 2 is 4. And second row, second column. So 3 plus 4 is 7. Right? This is x square. Right? And this x square, so I can say that x square 7 12 4 7 is equal to x times the matrix x, which is 2 3 1 2, plus y times the identity matrix, that's 1 0 0 1. And therefore I get 7 12 4 7 is equal to 2x 3x x and 2x plus y 0 0 y. So now I can add the two matrices. So what I will get is 7 12 4 7 is equal to 2x plus y, then 3x, then x and 2x plus y. And now I know that the corresponding elements should be equal. So corresponding elements should be equal, and therefore I can say that the element x is equal to 4. So x is equal to 4, and I can also say that 2x plus y is equal to 7, isn't it? So 2x plus y is second row, second column, is equal to 7, second row, second column. Therefore 2 times 4 plus y is equal to 7, which means y is 7 minus 8, which is minus 1. And therefore the answer is x equals 4 and y equals negative 1. So this was the last question in this particular session. I will pause for a few minutes and then we will end this particular session. I hope that solving matrices problems is now very well understood, and you will be able to attempt questions on your own.